So we've been looking at alkanes. What do we call hydrocarbons that have a double bond? They're alkenes. So you might want to guess what the name of this one is. It's 2 carbon, so it's eth, but instead of ethane, it's ethene. And this one is 3 carbons, so it's propene. Let's go back to our chart on naming, our table. Here we are. Now we can fill in some alkene names. We said ethene, propene, butene, and this does continue on down. Drop the ane and add ene. Why did I skip this one? There's no such thing as methane. Why not? An alkene has to have a double bond between carbon atoms. And so if you have just one carbon atom, you cannot have that. While we're here, let's look at the names of the alkynes. Alkynes have at least one triple bond. So there's no methine, but 2 carbons is eth-ine for alkyne. You pronounce all of these with a long I: butyne, pentyne, and so on. Okay, let's go back to where we were. What about this? What if instead of putting the double bond there, I write it like this? Is that a different compound than the propene? It's the same compound. This is propene again. It's just flipped. Flipped horizontally. So it's the same molecule, it's just flipped horizontally, so the double bond appears to be on the other end. We call those conformers. Remember, conformers. Same compound, just drawn a different way. What about this next one? It's bigger. Has 5. Okay, that makes sense. What about this though? What do we call that? We have a problem because these two are not the same molecule. These are a form of isomer. The double bond is in a different position, and the only way you can go from this top one to the one underneath is by breaking a bond and putting it somewhere else. So these are different compounds, and we need different names for them. And like a lot of things in this naming system, it would be nice if the name would tell us where the double bond is. So guess what the IUPAC says? We're going to number bonds. So this is bond 1 and this is bond 2. I started numbering on the end closer to the double bond. So I will call this one 2-pentene. On this bottom one, the bond 1. See if I number all my bonds. Bond 1 is double, so I will call this 1-pentene. And by the way, when you number them this way, that sets up the numbering for the carbon atoms as well. This is carbon 1 and carbon 2, and so on. So it doesn't even matter if I have some branches over here. I'm going to number from the end that's closer to the double bond. Let's try one. So if they're bigger, if these are, actually it starts after this. If their 4 carbons are larger, then there's going to be more than one place to have the double bond that matters. So if they're larger, you have to use a number to tell where the double bond is. So if you're naming an alkene, the first thing you do is you find your longest chain that includes the double bond, like so. On this one, I've drawn the long lines like the lab manual does because I want to show you what to watch for here. Remember that with these long lines, what's really out there on these ends are hydrogens. That's a hydrogen there. Okay, I haven't been showing those dashes and the H's, but they're there. So when I go to number my bond, this is bond 1 here. I don't count this one as bond 1 because it's a C to H bond. So I number from this end for my bonds. It's bond 2 that's double. That means I will also number from this end for my carbons. So that sets up my numbering for everything, including telling where this methyl is. So here, this is a methyl branch. And there's my little note about the numbering. So when we put together this name, we're going to start with the branch still. This is a methyl, so it's a 6-methyl. And then the last name, the 7 carbon chain is the last name. And it has a double bond, so it's heptene, but then I'll say 2-heptene. Okay, so again, the double bond sets up the numbering for everything. Number your bonds first if there's a double bond, and then your branches. Let's try this one. Good time to pause and see if you can do it without me. This is bond 1. So I'm numbering from this end for my carbons as well. So this is 3,3-dimethyl. And then the last name includes the number 1, bute for 4 carbons, ene because it has a double bond. I bet you can name this alkyne. Another good chance for you to try. Pause and see if you can get it. The longest chain is not straight across. I number from this end because it's closer to the triple bond. That means this is carbon 1. So I'll start my name with my branches again. 4,4-dimethyl 2-hexyne. 4,4-dimethyl 2-hexyne. No spaces. Well, very good. We've learned all. We can name anything now. We've learned all the rules for naming. Let's try going backwards. So we've been doing a lot of coming up with the name. What if I give you a name? Can you draw the structure? This is very, very easy. And this is the beauty of this naming system, is that the name tells you the structure. So to make it easy, what you do is you just start with the last name. So here's my last name. Hex, 6 carbons. And then I'm going to just number them left to right, kind of small so I can see. Okay, so it's a 6-carbon chain, but I also see that it has a double bond, ene, on the second bond. So I put a double bond here. And then I just go through, and on the 4th carbon I put an ethyl. And ethyl is 2 carbons like this. I can point that up or down, it doesn't matter. I tend to just point mine down. On the 3rd carbon, 1, 2, 3, I need a methyl. And on the 5th carbon, I need a methyl. You could have, if you have 2, you could point one up and one down, or you could point one up, it doesn't matter. But if you lay it out like this, left to right, numbered straight across, there's no reason to bend your main chain or anything like that. It makes it easy to keep track of things, and it also makes it easy to grade. Here's a little preview to an online quiz you'll be having. This is a lesson 8 quiz. I will give you a little bit, I'll give you a name, and essentially I give you a name that's wrong, but you can still come up with the structure that is implied by it. So what you do is you take my name and you draw it, and then you look at the structure and you rename it correctly. So let's see how this works. So start with the name. The last name is propane, so I'll make propane 1, 2, 3, and I'm kind of thinking of this as like this, 1, 2, 3. And then I need to do a 1,3-dimethyl. So on the 1st carbon a methyl, and on the 3rd carbon a methyl. That is the structure that is implied by that name. Well, now we look at it fresh. Usually you're going to need to renumber these. Do you see what we did wrong, or what I did wrong when I came up with this name? It should have been, the longest chain is this. This is just one chain. So the correct IUPAC name of this is just pentane. No branches. Let's try one more of these. The last name is pentane. I need 2 ethyl, 2 methyl, goodness, pentane. Get rid of my numbers. Can you see what I did wrong? So what do we do? Let's find our longest chain. I didn't find the longest chain when I did that, did I? Did that on purpose, but anyway, so now I see that this is really how it should be. Got a methyl, and it should be numbered from down here. So to put together the name, I'm going to start with my branches. 3,3-dimethyl hexane. Very good.